Hello, this is another video on climate science for people really in a hurry. Without reducing greenhouse gas emissions, our best estimate is that the Earth could warm by another about 6 degrees Fahrenheit by the end of the 21st century. But an appropriate question is, so what? We often hear about climate change as an environmental issue, but climate change is expected to influence human society more directly as well. So here I'm going to be talking about some results from some prominent research on the impact of global warming on a very important human system, the economy. In particular, these papers look at how temperature affects the productivity of human society as measured by annual gross domestic product per capita, which is just the value of all goods and services produced in a country in a year divided by the number of people in that country. The idea is that if climate change is going to affect GDP, then there should be some historical correlation between temperature and GDP that we can observe. So what is the best way to look for a relationship between temperature and GDP? You could look for a relationship across space in the current climate. Countries have very different GDPs and average temperatures across the world. The problem with this is that countries differ in so many variables other than temperature that it's very difficult to infer a causal relationship. Another thing you could do is look at long-term trends. So for example, New York has warmed by about 3.5 degrees Fahrenheit since the 1850s. But again, GDP has changed in that time for countless reasons unrelated to temperature, so you can't uncover a causal relationship. So instead of those two methods, what the research I'm discussing today has done is look at short-term or year-to-year fluctuations in temperature and GDP, which can be just as large as the long-term change. If there's a correlation with temperature and GDP on this timescale, the relationship should be that temperature is affecting GDP, since confounding socioeconomic factors would either be changing more slowly or they would not correlate with temperature. So when the researchers looked at the relationship between temperature and GDP across the world, they got different relationships for different countries. In some countries, warmer than average years are associated with higher than average GDP, and in some countries, warmer than average years are associated with lower than average GDP. It turns out that the relationship sign depends on the country's average temperature. Cold countries are more productive when it's warmer, and warm countries are less productive when it's warmer. So that means there's an optimum GDP, and that finds its value at about 13 degrees Celsius or 55 degrees Fahrenheit. So why does GDP have a relationship with temperature like this? Well, intuitively, an average of 55 degrees Fahrenheit is a pretty nice day for some productive economic activity. Imagine a low of 45 and a high of 65. Also, we know that as temperatures get warmer than certain critical thresholds, there are steep impacts on certain aspects of the economy. For example, the efficiency of outdoor labor and our yields of corn crops are dramatically reduced when temperatures are warmer than about 86 degrees Fahrenheit. This research shows that higher yearly average temperatures mean proportionally more daily temperatures above these critical thresholds, which translates into losses in average economic productivity for that year. Interestingly, though, this optimum temperature is not too different even for rich countries that do not have agriculturally based economies, meaning that the temperature affects the economy in many more ways than just through agriculture. Human health, mortality rates, and energy use being just a few examples. Also, the optimum temperature relationship generally holds both for rich and poor countries and has not changed a great deal over time. This means that historically, being richer or more technologically advanced has not really made economies more resilient against temperature fluctuations, meaning that it might be reasonable to extrapolate the temperature-GDP relationship into the future as the world continues to warm due to human-caused greenhouse gas emissions. So when you do that extrapolation, this is what you get for global warming cost changes in GDP for various regions around the world. Positive trends mean global warming increases GDP over time, and negative trends mean global warming decreases GDP over time. All these projections are relative to background GDP growth in the future, so negative trends don't necessarily mean a decrease in GDP with time. What they generally mean is less of an increase in GDP with time. The basic pattern is that countries that are currently on the colder side of the optimum value of 55 degrees Fahrenheit are helped out by global warming, while countries on the warmer side of the optimum are hurt by global warming. Since warmer tropical countries tend to be the poorest, and since rich countries tend to be near the optimum, this increases global inequality. The global average GDP extrapolation shows that the best estimate is that GDP per capita will be 23% less than it would have been otherwise without global warming. The large uncertainty is notable, and it suggests that there is a 70% chance that global warming will harm future GDP and a 30% chance that global warming will enhance future GDP. Keep in mind that these projections may severely underestimate the impact of climate change on GDP because they do not include many relevant effects of climate change, like changes in tropical cyclone strength or sea level rise. On the other hand, they also cannot include the adoption of inventions that might help ameliorate the impact of climate change, like wearable technology that would help people cope with high temperatures. And that's climate economics, or at least temperature-GDP relationships for people really in a hurry.